Good day, everybody. I am Dr. VVVS Murthy presenting the selection of composite material for structures. Based on the global availability and demand, steel and aluminum are selected as the principal construction materials in composite action with polyurethane foam. The World Steel Association forecasts a steel demand of about 1.84 billion metric ton in 2022 with a growth of 2.2% in 2023, and the value at the rate of $800 per metric ton, the demand is 1.5 trillion US dollar. Whereas aluminum as a global production in 2021 amounting to 67.343 million tons with a hike of 3.09% from previous year, valued at 159.32 billion US dollar. The composite material PU foam has a production of 29.9 million metric ton in 2021, valued at 1.7 billion US dollar. To achieve better strength to weight ratio, the steel and aluminum envelopes selected are of high strength grades. The steel with Fe 310 to 550 MPa, megapascal strength, and it is of light gauge between 2 to 4 millimeter thickness, and to achieve 30-year corrosion resistance performance, it is with galvalume coating. The aluminum envelope used is of high strength grade AA6061. The thickness used is 2 to 3 millimeter. Coming to the infill material, concrete and steel composites have been in vogue since 1950s, concrete being the infill material and steel contributing to the tension of the members. After 2000, rigid PU foam, polyurethane foam applications have taken pace. Even though foam as a structural material has been investigated since 1970s. Rigid PU foam is formed by chemical reaction and expansion of mechanical mixture of polyol and isocyanate liquids. Under loading, rearrangement of the foam pentahedron cell lattice structure gives a triaxial compression resistance equivalent to M15 to M20 grade concrete. And this is used in the present investigation, and the density of foam selected is between 100 to 200 kg per cubic meter, even though up to 700 kg per cubic meter of foam is possible to be produced. this material combination using steel and aluminum envelope in composite action with high density polyurethane foam as infill material offered improved average strength to weight ratio of 60 times compared to RCC and 40 times compared to steel, tested as structural elements subjected to compression and bending. Coming to the sustainability, which is a parameter nowadays mandatory and very important based on BREEAM, that is Building Research Establishment UK, Leeds USA, Green Star Australia, etc., with about sustainable goals, about 20 such goals based on carbon dioxide emissions, waste generation and recyclability, environment impact, workability, safety, and overall economy. The BREEAM rating, for example, is supposed to be excellent when it is greater than 85% in score. One of the notable examples of the sustainability of steel is the Cooperative Group headquarters building in Manchester, UK. This building, providing 30,000 square meters of office space, was constructed with 2,000 metric tons of steel framing, and all the facades as well as roof atriums were with glass. The building was completed in 2013 and stands testimony for a decade of successful performance. So far as sustainability of aluminum and foam are concerned, the external envelope comprising of the entire roofing, the wall panels, shading devices, door and window frames, and facades. All these areas, the use of aluminum in composite action with foam as an infill material for sandwich panels is ideally suited. The foam offers both stiffness to the panel as well as insulation properties for the envelope. In addition to the stiffness and insulation to the structural members, the PU foam also offers sustainability attributes like good fire resistance, negligible water absorption, energy conservation, safety and workability, in addition to less carbon emissions. Having established the successful performance of the innovative composite with a high strength steel or aluminum envelopes of light gauge and infill PU foam of PIR, that is polyisocyanurate type, with better strength and fire resistance, we are now pursuing the investigation of slenderness aspects such as B by T, that is width to thickness, and L by R, length to radius of gyration, ratios of structural elements, and diaphragm action of frame infill panels. Panels can be for walls or floor. The connection aspects of the application is also being taken up in two ongoing research projects. Finally, the overall status of the research. Behaviors of compression, tension, bending, and torsion are established. The combined forces and their effect, composite foam infill, that is PU foam mixed with lighter inert infills to reduce the cost, slenderness and diaphragm behavior are being pursued. Thank you.